Yes. On Thursday? Yes. All right, so recapping of what we did last Thursday, we did arc length and area of a sector. And again, sorry that the original video did not save. So we're gonna kind of just do a brief overview of it. And I will post the completed notes along with it and go from there, okay? So area length, arc length and area of a sector. These are two topics from geometry, okay? These are two topics that you learn in geometry that we're reiterating here in pre-cal. So the first thing we're gonna do is look at arc length. Your arc length is a portion of your circumference, right? It's not the full circumference, it is a portion of your circumference, okay? So in geometry, you learn to find arc length by taking the degree of the angle, dividing it by 360, times it by 2 pi r, okay? That's because you only work with the degrees. Does that make sense? Okay. Now, what we're going to later learn today and reiterate in our 7.6 is that arc length can simply be x times r or theta times r. Okay. So your x is in radians instead of in degrees. All right. So it goes from being a multiple variable to just being here's your angle in radians and here's your radius. Find the arc length. Okay. All right, so when you're finding arc length, there are typically two arc lengths. You have a minor and a major arc. Okay, do those sound familiar? Minor arc and major arc? Kind of. Okay, your minor is clearly your smaller arc. Okay, your minor is your smaller, your major is your larger. So when you look right here, we have a minor arc of 120. So therefore, our major arc would be 240, right? Because together they have to equal 360. Agreed? All right. And all you're doing is plugging them into the formula of x divided by 360 times 2 pi r, where x is your degree of your arc, of the angle of the arc. So for example, here, 120, I'm going to plug it in, and you're going to simplify. 120 over 360 becomes 1/3, right? 12, 36, 1/3, okay? After you simplify the fraction, then you're going to multiply. 1/3 times 12 pi equals 4 pi. So your arc length is 4 pi units. Okay? And that's all you're doing there is you're plugging in the values. Does it make sense? Yes? Yeah. Questions about using the arc length formula? Okay, so as you look, there's just more examples of finding the major and minor arc. So if I'm looking for if I have 300 as my major, then my minor has to be 60. And so depending on what it's asking, I can find the arc length by plugging in 300 and 360 into the formula. Okay, that's pretty much it for that. Another example, if you need it, I can give it to you, but that's it. All right, area of a sector. Area of a sector is a portion of the area, okay? It's not the entire area of the circle, it is a portion of it. It's a portion of it. And so with that being said, you're going to take the degree that that portion is consuming, you're going to plug it in and then go from there. Now, if you're given radians, which is what we're working towards now, instead of having all of this, it becomes 1/2 x times r squared, where x is your angle in radians. Okay, so our example that we did was find the area of the sector below. So it told me that my radius is 6, my angle is 120. So all I did was take 120 and plug it in. So 120 over 360 becomes 1/3. 1/3 times pi times 36 is 12 pi units squared. Okay. Again, it is all formula based. Arc length and area of a sector is all formula based. Take the value, plug it in, simplify. Take the value, plug it in, simplify. Okay. The only time that it may get harder is if it's asking you to do both. Find the arc length and the area of the sector. That's a two-step situation, right? I'm going to find one, find the other. And you would know whether you're finding the minor or major based on the fact what's shaded. So in this case, we're finding our minor because the minor is what is shaded. Yes? All right. Next, what if you have to go backwards? Okay. What if they give you your arc length, but you don't know your angle? Okay.
You would divide.
You would have, I mean, you'll do a little bit of division, yes. But clearly here, you can easily see, okay, well, this is obviously 90 degrees. Yes, it is, okay? But I did that on purpose so that you can at least go through the process of seeing why it's 90 degrees, besides just visually saying that's a quarter of a circle, right? So we know our arc length, so we're gonna be using the arc length formula. So we have arc length is 8 pi, and we have x over 360 times 2 pi, and our radius is 16. We circle the x because that's our unknown. That's our goal to get by itself, okay? When you have a number or variable in the numerator, as long as it's not being added or subtracted, it can be separated from the fraction. So since x is not being added or subtracted, I can separate it from the fraction, okay? And then we have 2 times 16 is 32 pi. So I'm left with 32 pi over 360. I prefer to reduce before I do anything. Do you have to reduce? No, but why not work with smaller numbers, right? Oh, well. So 32 over 360 can become 8 pi over 90. 8 pi over 90 becomes 4 pi over 45. Okay, so now I'm down to 8 pi equals 4 pi over 45. How do you cancel out a fraction? You multiply it by what? By the reciprocal. So instead of 4 pi over 45, it's going to become 45 over 4 pi. So that cancels out. And what I do to one side, I do to the other. So the pi's cancel out. 8 divided by 4 is 2. And 45 times 2 is 90. Okay. So that is why we can confirm that it is 90-degree angle. Okay. So the last example is now you have to find your radius. So given the amount of information you have, find the radius. So this time it says your area of your sector. So which formula are you working with? Area of a sector. So I'm going to plug in everything I know. I know the area of the sector. I know that the angle is 120, but I do not know the radius. So we use inverse operations to get R by itself. Again, I prefer to reduce before I do anything. So I have 120 over 360, and 120 over 360 becomes pi over 3. Okay. And again, how do we cancel out a fraction? Multiply by the reciprocal. So we're going to multiply both sides by 3 pi. Pi's are going to cancel out, and we're left with 3 times 432. 3 times 432 is 1296. And we're going to take the square root, and that leaves us with 36 feet, because the square root of 1296 is 36. Okay. On your assignment, you're going to have the first half of the assignment is finding area and arc length. Okay. Or no, your assignment is actually all on campus this week. And so first you'll start off by finding the arc length, and then using the arc length to find the angle or the radius. Okay, same thing for sector. All right, so that was 7.5. Again, it's all formula based as you're working.